Welcome to the Tuva project. Today we're going to talk about an algorithm for grouping claims into encounters. We all know that when we do healthcare analytics, we often start with individual medical claims, and each medical claim has its own start date and its own end date, and we're often in situations where we have multiple claims starting and ending at different points in time, and we want to be able to merge these claims into a single encounter when they all belong to the same encounter. It doesn't matter what specific type of claim we're talking about now. For example, we could be talking about acute inpatient claims that would be merged into an acute inpatient encounter, or we could be talking about emergency department claims that would be merged into an ED encounter. The point is that we want to merge multiple claims of the same kind into a single encounter. Now, if encounters only ever consisted of at most two claims, then it would be trivial to merge them into encounters because all we had to do is just compare all possible pairs of claims, and then for each pair, we decide if those two claims need to be merged according to some logic criteria. The specific logic criteria we use to merge any pair of claims could be whatever we want. For example, we could say that we're going to merge any two claims if they belong to the same person and they overlap in time. Or we could define a more strict criteria and say that we also require the claims have the same facility ID. It could be whatever logic criteria we want. The point is that if encounters only ever consisted of at most two claims, it would be trivial to merge them because we would just compare all possible pairs and then for each pair decide if they need to be merged. But in practice, encounters may consist of multiple claims that are linked together in this way, and they all need to be merged into the same encounter. So for example, let's say that we decided any two claims should be merged if they have belong to the same person and have some kind of overlap in time. So in that situation, when we compare claim 1 and claim 3, we would not merge these two claims because they do not overlap in time. But claim 1 overlaps with claim 2 and claim 2 with claim 3 and claim 3 with claim 4. So by transitivity, all of these claims should be merged into the same encounter. And so what we need is an algorithm that can traverse a series of pairwise linked claims and determine if they should all be merged into the same encounter. Typically, this is done with recursion when chains of claims can have an arbitrary length. The problem with recursion is that it doesn't scale, first of all, because the computational time tends to blow up with the problem size. And second of all, recursion is not universally supported in all major SQL data warehouses. So here we're going to explain a SQL algorithm that can do this kind of merging of chains of claims without using recursion, and that it's very efficient. So at a very high level, the algorithm has two parts. First of all, we have to order the claims chronologically in time. And second, we're going to merge claims that need to be merged into encounters. So we'll start with the first part. First, we order the claims chronologically. We order by end date. That is a convention that we're going to have. So if claims look like this in time, this would be the first one, this would be the second one, this would be the third, this would be the fourth, this would be the fifth, this would be the sixth, because we're ordering by the end date and not the start date. And the reason for ordering by the end date and not the start date is that we're going to eventually check if each claim merges with any claims that had any active days after the claim ended. So we care about when the claim ended and not when it started. So we can order with a statement that looks like this, where we use the start date to break any ties. And if there's still remaining ties, we could use an arbitrary field like the claim ID to break those remaining ties. So after the claims are ordered in time, now we merge claims that need to be merged into encounters. And we're going to be doing this using a concept that we introduce here, which is a concept of a close flag. A claim gets a close flag of 1 if it is the last claim in an encounter. So for example, if we have claims that look like this in time, this claim gets a close flag of 1 because it is the last claim in this encounter, and this claim gets a close flag of 1 because it is the last claim in this encounter. So how do we assign close flags? First, we order the claims chronologically. Then we define some logic for merging any given pair of claims that we compare. The logic, again, can be anything. We can say we're going to merge claims if they belong to the same person and they overlap in time, or we could define more strict logic and also require that they have the same facility ID, or we could define any logic we want. But it's logic that when you use to compare two claims, you can decide if those two claims should be merged. Then for every claim, we check if it should be merged with any claims that come after it. So for example, claim 1 should be merged with claim 2, claim 2 should be merged with claim 3, claim 3 does not merge with any claims coming after it. So then we assign claim 3 a close flag of 1. Similarly, claim 4 should be merged with claim 5. Claim 5 should be merged with claim 6. Claim 6 does not merge with any claims coming after it, so we assign claim 6 a close flag of 1. So step 4 is assigning a close flag of 1 to a claim if the claim does not merge with claims that come after. And we also require that the claim does not have claims coming before it that merge with claims coming after it. This is a subtle but important point because you can have situations like this where claim 1, claim 2, and claim 3 are ordered in this way in time. Claim 1 merges with claim 2, claim 1 merges with claim 3, but then claim 2 does not merge with claim 3. This could happen because of how you defined your logic criteria for merging any pair of claims. For example, if you require the discharge disposition of a claim to have a certain value to merge with the following claim, maybe claim 1 meets that criteria to merge with claim 3, but claim 2 does not. So you could have a situation like this. So you might say that 2 gets a close flag of 1 because it does not merge with any claim coming after it. But in fact, all 3 claims should be merged because of transitivity. And so claim 2 should not have a close flag of 1 because it is not the last claim in the encounter. So that's why we require step 4 to have that other step of the claim does not have claims coming before it that merge with claims coming after it. So these are our steps. We order the claims chronologically, we define logic for merging any given pair of claims. For every claim, we check if it should be merged with claims that come after it, and then we assign the close flags of 1 to all the claims that need a close flag of 1. Every other claim gets a close flag of 0. So once we have assigned close flags to all the claims, then for each claim, we find the nearest close flag of 1 that came after it. So for example, for claim 1, claim 3 is the nearest close flag of 1 that comes after. For claim 2, still claim 3 is the nearest close flag of 1 that comes after it. For claim 3, it is itself the nearest close flag of 1. And so all 3 of these claims get claim 3 assigned as their nearest close flag of 1. And so we assign the claim ID of claim 3 as the encounter ID for all 3 of these claims. All 3 of these claims are part of the same encounter, and their encounter ID is the claim ID of claim 3. Similarly here, claim 4 has claim 6 as its nearest close flag that comes after. Claim 5 has claim 6 as its nearest close flag of 1 that comes after. And claim 6 is itself its nearest close flag of 1. So all 3 of these claims get claim 6 assigned as their nearest close flag of 1. And so therefore we assign the claim ID of claim 6 as the encounter ID for all 3 of these claims. So this is how we use the concept of a close flag to assign encounter IDs to claims and therefore group claims into encounters. Because once we have assigned encounter IDs to all the claims, we have essentially grouped the claims into encounters. Okay, we have conceptually gone over how the algorithm for grouping claims works, and now we're going to look at the actual code for the algorithm. So I'm going to go to the Tuva Health GitHub page, and there's a repo called Tuva Notebooks. So if I go here, there is a notebook called Algorithm for Grouping Claims into Encounters. So I'm going to open this notebook, and this notebook has the code for this. Anybody can go to this URL and have access to the notebook and run it and see the source code for this algorithm. So the first few cells here are just importing and installing what we need to be able to run this against .db. I'm just going to run these cells. What I'm doing here is I'm importing the medical claim table, the Tuva medical claim table with synthetic data from Tuva public resources. So that's going to create a table in DuckDB called medical claim with synthetic data, and that's what we're going to run our algorithm against for the sake of this demo. And here is the actual code. So for this example, we're going to merge emergency department claims into ED encounters. And so the first thing we want to do is define what is an ED claim. We're going to start with institutional ED claims because those are the claims that we're going to merge into ED encounters. So this is just a definition of an institutional ED claim. It's a claim with claim type institutional, and it has either a HCPCS code or a revenue center code indicating that this is an ED claim. So now that we have these institutional ED claims defined, these distinct claim IDs, we're just going to join the medical claim table to these ED claims. We inner join it to select only the ED claims. And then for each individual claim, we're grouping by claim ID. We're going to define a merge start date and a merge end date. These are the dates that we're going to use to merge claims to other claims. These are the dates that determine where the claim starts and ends for the purpose of merging so that we can decide if the claim overlaps with other claims. So once we have identified all the relevant claims we want to merge and identified a start and end date used for the purposes of merging, now we can run the algorithm. So here's where the algorithm starts. And I'm just going to show you where these CTEs are and what they're doing. But basically, this mirrors the logic that we just reviewed of how the algorithm works. So the first thing we do is we order the claims chronologically. This is what we're doing in this CTE. We're adding a row number that orders the claims chronologically for each person. We start ordering with end date, but we use the start date and claim ID as tiebreakers. And then we compare every claim to every other claim for each person to see if each pair of claims should be merged or not. So we're just joining these claims with a row number to themselves. We're only joining rows to rows that are bigger than itself, because if we've already merged row 2 to 3, there's no need to merge row 3 to 2. And this is the criteria, the logic criteria that we define to decide if any two claims should be merged. So this logic criteria could be whatever we want. We could change this to whatever we want. Here we're only merging claims if they overlap in time. So this is the logic criteria to decide if two claims overlap in time. It's either the start date of the first claim is between the dates of the second one, or the end date of the first claim is between the dates of the second one, or vice versa. And so once we've created a merge flag indicating if any given pair of claims should be merged or not, now we can take all the pairs of claims where we have a claim merging with a larger claim. And here we're taking all the distinct claim IDs that merge with the larger row number. So these are all the claims that merged with a claim that came after it. And here we're selecting all the claims that had a claim coming before it merging with a claim coming after it. So now we introduce a concept of a close flag. This is the key concept in the whole algorithm. A claim gets a close flag of 1 if it is the last claim in an encounter. So we're going to assign a close flag of 1 when a claim does not merge with claims coming after it, or it does not have claims coming before it that merge with claims coming after it. That's what we're doing here. And so now we're taking every claim and finding all the close flags of 1 that come after that claim. And then once we've identified all close of 1 coming after each claim, we can find the minimum one for each claim, which is what we're doing here, because that's going to be the one that we're going to use to assign an encounter ID to each claim. And then we just add that minimum closing flag to each claim, and we use that to assign encounter IDs here. This is what we're doing. And the encounter ID is just the claim ID of the closest claim with a close flag of 1 for each claim. So let's run this. This gives us a table that has all our claims. There's one row for each distinct claim. For each claim, we have the person ID, some fields of interest like the facility MPI, the start and end date, and then we have the encounter ID for each claim. So we can, for example, count how many claims do we have here. So let's say select distinct, count of distinct claim ID. So we have 669 distinct claims. How many encounters do we have? Distinct encounter ID. So let's run this. We have 662 distinct encounters. What if we have different logic? What if for merging any given pair of claims? So here, what if instead of merging claims, if they overlap in time, we also require that they have the same facility? For example, here we say facility NPI of claim A is equal to facility NPI of claim B. This should be B. So if we require a stricter criteria for merging any pair of claims, the claims must overlap in time and have the same facility. In that case, how many encounters do we have? 667. So in that case, we have 667 distinct encounters. That makes sense. There's more encounters now than we had before because we had stricter merge criteria. So we merged claims less frequently. So therefore, there's more encounters. So you can play around with this, but the purpose of this is showing you where the CTUs are and what they're doing, but they mirror exactly the logic that we reviewed before.